Hey guys, I'm investigating this setup and I'm trying to see if I can get um, a Mr. Preva's like setup um, into magnetic resonance. So basically what I'm thinking about is that if we tie the two part and output coils in series, uh, since they have some interwinding capacitance, right? Um, the equivalent circuit should be like this. So I have a cap in parallel with POC1 and another cap in parallel with to POC2. Um, okay, and this, as you know, parallel resonance um, gets the impedance up to maximum. So, um, but series resonance gets the impedance down to minimum. So I'm thinking that this creates pathways for the current, right? So we could have a series RLC circuit in here through this cap in this coil, and another one through this coil and this cap, right? So we have two pathways possible for current to flow with minimum impedance. So I did some measurements. Um, First, for POC1, the resonance frequency is 950 hertz. Um, Knowing the inductance, um, the resistance is almost the same, is basically the same. Um, okay, I did the same measurements for POC2. Um, okay, and then I calculated these capacitors based on these values. So basically, if an RL circuit resonates at this frequency, and the coil has this inductance, then it should have this capacitor in parallel. And I did the same for the for part and output coil 2. Okay. Uh, and then I defined the two series RLC circuits, and their resonance frequencies are around these values. Um, okay, and I used these values to I tried these values and the subharmonics um, to see if I can get closer to magnetic resonance. But I was unlucky until now. Um, Maybe tomorrow I will get another idea about these numbers. Okay. Second, I did this. Okay, I tied the partner output coils in series, open-ended, and I did the same measurement that I did individually. So basically, I injected the signal here, a sine wave, and then I measured the the signal at this end, um, and I noticed the resonance frequency is at 141.9 kilohertz. Um, Knowing and I measured the inductance of the series coil. Basically, the two coils are in series, and one is clockwise, the other counterclockwise. Uh, in opposing magnetic vectors, so the inductances are almost completely canceling. So if you see here, the full um, values of the inductances are these, and the series inductance is much lower, 12.49 millihenries. Um, and this gives us a capacitor of about 100 picofarads. So basically, this coil, in order for this coil with this inductance to resonate at this frequency, it needs to have a capacitor with the value of 100 picofarads. Um, nowhere near these values, and nowhere near the values in series. So if I put 369 two capacitors in series, I apply the formula 1 over C is 1 over C1 plus 1 over C2. That gives us, I didn't write in here, but that gives us about 180 picofarads. So it's not near this value. Okay, I tried this frequency also with AC, square wave AC provided by the Quadratron, the tied-in H bridge, and um and I got some sound, but I can't say it's magnetic resonance. It's not. I didn't find what I was looking for yet. Okay, then I measure the capacitance between the partner and output coils. This is the value. So basically, I disconnected them and tied my capacitance meter, which is a pretty good tool. Pretty precise, and this is the value. So basically, if I put in the formulas, I put this inductance with this capacitance, I get this resonant frequency, and I tried this value and subharmonics of these values of this value, and I didn't find I didn't find anything interesting until now. But I noticed something in fiddling with the device. I noticed something interesting, and I'm going to show it to you. So basically, what I have in here is um, my probe, which is measuring the voltage over this coil, which is POC2, and I'm measuring the current between the coils. So it's in the middle from POC2 to POC1. Basically, I want to see if this current um, looks like. I want to see if this current is transforming from AC to DC. Um, that should be a sign that the coils are in magnetic resonance. Okay. Okay, and let me show you what I noticed. Okay, I'm going to raise the input voltage slowly and watch the voltage over that coil. it's dancing like crazy. Minimum current consumption, um, and I think this is the frequency. It's not very precise. I can get. Um, let me let me work a little with it. I'm increasing the frequency. It's not. It's not emitting too much sound. Very um, discrete sound. But the I don't know. I can't tell why, at least until now, um, what this frequency is. This evidently it's a resonant frequency, but I don't know what it is. What are the numbers that match it? Um, I'm going to go over the numbers tomorrow with a clear head, um, and see if I can find a match. Um, okay, let me go faster over this. Okay, the what's important is that the ping trace is not going on the DC side, and I noticed that somewhere, um, maybe I can find the point where the device becomes more noisy. I think it's if I use slightly, not a slightly, maybe a even more um, um, lower frequency, much lower frequency. Okay, right about there, around 1.2, somewhere in there, 1.2 kilohertz. Okay, I'm not sure what this means. Maybe if I can understand more tomorrow. Thank you. Bye.